How's it going, everybody? Today we were going to be talking about simplifying algebraic expressions. So that is just another term for combining like terms. So what we're doing is taking algebraic expressions where you have like 2x plus 3 plus 5, things like that, and basically simplifying them down. So this is kind of like a building block for what we'll do in algebra and further on in high school math and things like that. So we're going to look at some simple computation problems, but I also want to apply it to some real-world connections that we'll see with geometry and things like that. So I hope you find it helpful. Please do me a favor and subscribe to the channel if you like. It'll help me out. And then leave a comment of anything that you would like to see me go over in the future, or if you're having any issues still with this topic that I can create for you. Thank you. Okay, with this first problem here, as I said, what we're going to do is combine like terms. But what's tricky about this is that you have to look at this right here and understand that that actually is not to the second power, where it can be confused with these other problems where you have 8k squared minus 3k squared. You're not going to combine it with that. So this actually can be simplified. All right, so 3 squared we know is really just 9, all right, because that was just unsimplified. And then we can go back and highlight our like terms. All right, so I always tell kids you can use circles, underlines, double underlines, color coordinate, however you want to do it. So we have 8k squared, right? We have a minus 3k squared, right? That's the only thing that has a k squared with it. Then we have plus 4k minus k, and now we have this plus 9 and plus 5. All right, so now we're going to go ahead and simplify these by combining them. And you also want to have the term that has the most going on at the front. So in this case, it would be the k squareds, and then go in descending order. So we have 8k squared minus 3k squared. So you take note of the sign in front of this, right, which indicates that we're going to subtract. So we have 5k squared. I always like to cross them out as I go so it's less to look at. All right, then we want to go to our k's. All right, we have plus 4k minus k. So we actually will subtract. We end up with a positive 3k. So they're out. And then we simply have 9 plus 5. So the single constant goes last. So because this has an exponent, this doesn't, and this has no variable or exponent at all, this would be the correct order. 5k squared plus 3k plus 14. Right, this is a great real-world application type problem and also involves some geometry. So what they want us to do is write and simplify an expression for the perimeter. So one of the things you got to make clear here is that you're not going to get like a single-digit answer, all right? So we have a lot of unknown terms here. Well, we have y and x. So we know that when we're finding perimeter that we're going to add them all up. So let's start up the top here. We have x, and we'll cross that out, plus 4y, all right, plus 3x, plus 2x, plus 4, plus 2y minus 1, plus y plus 2. All right, so what we're going to do is we'll highlight our like terms again. We have an x, 3x, 2x, and I believe that's all our x's, all right? Then we have 4y plus 2y plus y, and then we have positive 4 plus 4 minus 1 plus 2. All right, so let's go with our x's first. X, 4x, and 6x. So x, 4x, 6x. All right, we'll go with our y's now. 4y plus a single y, 4y plus a 2y is 6y, plus a single y is 7y. And then here you got to be careful. 4 minus 1, we're looking at the sign in front of it, so that gives us a 3. Then we add the 2, that gives us a final answer of 5. So that would actually be your perimeter, believe it or not. Okay, so that would be our lesson on combining like terms or simplifying algebraic expressions. Take note that you always want to look at the sign or operation that's taking place before each term. So if it says to subtract, you want to make sure that you're subtracting. We'll revisit this again when we start talking about adding and subtracting integers, which are signed numbers, and go over those rules. So some of the mistakes are just staying disorganized. So it's always good to highlight. That way you can kind of make a checklist and cross off it as you go, and it makes it much easier on the student. With those perimeter problems as well, it's good to have it drawn out or be able to cross out as well for those. Okay, so I hope you find it helpful. And if you have any questions, please feel free to leave a comment below.